screen share. So which questions do you guys want to do?
1 through 18.
A lot of them.
I agree.
I had no idea how to do number 6.
Yeah, me too.
Start with number 1, or what do we start with?
Let's do like number 3 or 4.
Yeah, those ones were harder.
Okay.
The only one, number 1, I couldn't get was E.
I was just I knew the concept, but I was like, am I supposed to plug this into my calculator? Is that allowed or what? And I was confused.
Gotcha. Now I'm like, I probably just need to, I'm gonna bring this up on this machine and look at it as well, because I'm like, you know what, now that I'm here, I feel like I need to see it, or else I'm gonna know all the ones that you guys are referring to. Okay. Calculus. Did we decide on number 3, or did we decide on part of number 1?
I think 3.
3. Okay.
Yeah.
Sweet. Number 3. Everybody seeing screen share, right?
Yeah.
Yeah.
Okay. Okay, yeah, because it does have all these parts, right? A, B, C, D, E. So, I mean, essentially, especially something like number 3, I think we might be able to take the integral of this without a calculator. But to be honest, I don't really know what this thing looks like without a calculator, right? So,
oh, that one's like a sine wave, but with 2 humps. It was really weird.
And I'm just gonna go ahead and put it on Desmos here because I can, because it's gonna be like figure out where we're going. Can everybody see Desmos on my screen?
Yeah.
Yeah.
Sweet. Y equals 5. Oh, I probably should put sine in parentheses. Sine of x squared, and then cosine x. Yeah, that's really gross. That's interesting though. So if we were going from 0 to 2 pi, I mean, Desmos is nice because we could actually make this go by pi, which is really great. Oh, I don't want the y-axis to go by pi. I want the x-axis to go by pi. So this is the part where it would be nice to have a graph, so you can actually just say when it's moving left, right, and stop, right? Because this thing is above. So do you guys remember which way it's going if it's above the axis?
Right.
Right.
Yeah. So it's going to the right from 0 to pi over 2, and again from 3 pi over 2 to 2, and then it's going to the left from pi over 2 to pi, and from pi to 3 pi over 2. Technically, right at pi and at pi over 2 and at 3 pi over 2 is where it's quote unquote stopped. Is that okay for everybody?
Mm-hmm.
Sweet. But that would be, I mean, I would say if it's not your average, like 3 and 4, like 1 is okay because we kind of know how to graph that in our head, and 2 is just a line. But 3 and 4, I would say feel free to graph it to see where it's going left, right, and stops, because we don't, except for like plotting things by hand, which we don't want to do. We really don't know how to do that. So yeah, now we'll go back to the whiteboard here. Actually, you know what? I'm just going to go here. I think that'll be easier. Nope. There we go. Okay. So then we said it's going from to the left from 0. Nope. It was going to the right.
Did you mean to put number 3?
Yes, I did. Thank you. Perfect. From 0 to pi over 2, right? And from 3 pi over 2 to 2 pi. It's going to the left from pi over 2 to pi, and technically from pi to 3 pi over 2. And the reason I separate those and don't just say from pi over 2 to 3 pi over 2 is technically it's stopped at pi over 2 pi and 3 pi over 2, because that's where it's hitting the hitting the axis, so that's where its velocity is 0. So it's either like stopping and switching directions, or maybe stopping in the same direction really briefly. That's kind of what's going on there. Is that okay for everybody? All right. So now here is honestly D and E are the big kickers, especially in how to do them. All right. Because if you're able to double check yourself using NINT, that's cool. But displacement, do you guys remember what we have to do to find displacement?
It's just the integral from 0 to 2 pi.
Yeah, this is what's awesome, is this is just the integral from 0 to 2 pi. We don't have to do anything making positive. We just take whatever the interval they give us is, put it as our bounds, put this guy in here, and go to town. And honestly, I mean, this is still not great. I mean, I'd probably rather NINT it, but this one's not horrible. Because if I bring the 5 out, this is from last chapter. I'll give you guys a hint. It's either Q or it's a U and V problem. What do you guys think it is?
Q.
Aha, it is, because Q, if we let Q be sine, don't make Q sine squared, that'd be too difficult, but if we let Q be sine, what's dQ?
Cosine t dt.
Boom. And now we can just,
And the cosine goes away.
say that again?
And the cosine goes away.
Exactly, yes. So we're gonna have 5 on the outside, integral of Q squared cosine t dq over cosine t, cross out those. And backwards from Q squared is Q cubed, right? So this would be 5/3 Q cubed plus C. But this is where I'm going to erase the E and just come down here. This is where we don't need the plus C anymore, because we're basically doing 5/3 sine cubed, but we're going from 0 to 2 pi. Now, I'm going to plug these in, but I'm about to be like, oh, I think I could have predicted that this happened from the graph. Do you guys remember how the graph was like a hump up and then 2 humps down and then another hump up?
Yeah.
My guess is that all these are going to cancel out. If we plug in 2 pi, isn't sine of 2 pi 0?
Yes.
Yes.
Yeah. And then sine of 0 is 0. So you plug in 0 and cube it and take it times anything, it's 0. This is 0 minus 0, which is 0. So the displacement I probably could have predicted. Is that okay for everybody?
Yeah.
But for part E, we actually just did half of our work for us. Because don't go through and read, like we're going to have to maybe do, my guess is, would you guys guess that the integral from 0 to pi over 2, that was like that first hump. You remember this thing looked like this-ish, right? My guess is that all of these things are the same area. Is that okay for everybody?
Yeah.
So my guess is that we just have to do one of them, and then we're gonna be able to double it. Maybe we'll just do from 0 to pi over 2, which is this one, and then do from pi over 2 to pi, which would be this one, and just make sure that they're the same, positive, negative, and then I think we could just basically maybe use one of them and quadruple it. But here's the thing, everybody, do not go back and do all this work that I have in pink, right? Because essentially, even though we have different bounds and we're going to get negative things to make them positive, this integral is still the same. So like we could do the same work, right? And we're just going to be right here at 5/3 sine t cubed from 2 pi to 0. Or instead of from 2 pi to 0, though, make it pi over 2 to 0. And plug it in. And when we plug in 0, we're still going to get 0. Oh, I got to go back and admit somebody. Hang on. What do you get when you plug in pi over 2?
Uh,
5/3.
Yeah, because sine of pi over 2 is 1, and 1 cubed is 1, and 1 times 5/3 is 5/3. So this is just 5/3. So here's my prediction, is if we get 5/3, or well, we should get negative. If we get negative 5/3 out of this one, then I'm pretty sure that all of these 4 humps are just the same, and we can just take 5/3 and take it times 4, and we'll have our answer. So if we plug in pi, sine of pi is 0, and so that's 0. minus, and then plug in pi over 2, we get 5/3. So that's negative 5/3. So my prediction is right. So basically, this hump would be 5/3. This one's negative 5/3. This one's negative 5/3, and this one's positive 5/3. But for total area, you got to make them all positive, right? So it's just going to be 5/3 times 4, which is 20/3. And that's your final answer to E. That was a good one. Welcome, Olivia.
Hey, sorry I'm late.
No problem. We just finished number 3. So
All right, I'm good on that one.
yeah, watch the first part if you want. Did you guys want to do number 4?
Yeah, I only got D.
Yeah, no problem.
I definitely just like eyeballed the displacement on 1 through 4,
Yeah.
and I didn't do the math.
Agreed.
That's
Yeah.
now make this thing go away. Ah.
It was 0 on all of them, wasn't it?
That's what
Yeah,
I
that's
got.
what I got.
Not going to stand on the break.
Oh, well, that's nice. It was 0 on all.
Also, I realized you can like find the area from the graph, and it made me happy because it looked cool.
Hey, that's pretty sweet. So let's only do part E, number 4. But we'll talk through all of the other things as I put it on Desmos, okay? So this is the equation. So I'll come over here to Desmos, type that in, and then we'll just talk about A through D, but I won't write them down this time. So Desmos.
Oh.
E to the, whoa, where did that theta come from? What in the world? E. There we go. All right, does that look good to everybody?
Yeah.
Oh yeah, I will say, I mean,
Yep.
wish I could highlight parts of this in marker right now, but I don't know how to do that.
No,
But I agree with you guys that the displacement, like to make this one more interesting, they should have used not 0 to 2 pi. You know what I mean? They should have used 0 to pi or something, because this is interesting. It becomes like this thing, even though it has E in it, has a period really. You know what I mean? It repeats itself. So I agree with you guys. The displacement is going to be 0. When is this thing moving to the right?
From 0 to pi over 2 and 3 pi over 2 to 2 pi.
Perfect. So that's actually really weird that it's like last time, but this thing isn't. This thing basically isn't symmetrical. So we're going to have a little bit of a challenge on our hands, but maybe not necessarily, because so it moves to the right from 0 to pi over 2, like Abby said, 3 pi over 2 pi, and it moves to the left from pi over 2 to 3 pi over 2. This time we don't have to split that up, and then it stopped at pi over 2 and 3 pi over 2. Displacement is 0, and it's basically because you can see that like the area on top kind of mirrors the area on the bottom. So my guess is, I mean, if you guys are okay with this, do you guys just want to find the integral from pi over 2 to 3 pi over 2? We'll know that that's negative, but we'll make it positive and we'll just double it because we know that that's what's on the top. Cool. And if we weren't sure, I mean, the good news is if we weren't sure, we could probably end up double checking part D really, really quickly afterwards, because we'll do all the hard work of finding the integral here. So let's do pi over 2 to 3 pi over 2 of this thing. What method do you guys want to use to find this integral?
Substitution again.
Yeah, for sure. With sign again, right?
yeah.
Perf. Because then we're just going to have e to the q dq, because sine goes in there and the cosines cancel out, right, when you move them over again. So what's backwards from e to the q?
E to the q.
Boom, plus c, but we don't need that. We just need e to the sine t, so we can plug in pi over 2 and 3 pi over 2. Okay, so what is sine of 3 pi over 2?
-1.
Yes, so we're going to have e to the -1, which I'll just leave like that for right now, minus, and then sine of pi over 2 is 1, right? So e to the 1, which I don't need. So this right here, if you wanted to, you could just leave this as your final answer. If you got the decimal, because this is the same as 1 over e minus e, right? So this is definitely going to be a negative number if I'm looking at it, because 1 over e is some decimal, because it's 1 divided by 2.71 or something, and this is 2.71. So, I mean, this might be something. I'll just use the calculator on my phone really quick. If I do 1 divided by 2.71, that equals 0.369. So if I take that minus e, I get negative, so this minus 2.7, negative 2.35. So that is the area below. And if we make that positive, so 2.35, and then double it, we're going to get approximately 4.7, right? Ish is the answer to part E.
When do you know how to how do you know when it's gonna be like double or times 4?
That is a good question. That goes back to, I should have left my other graph up on Desmos, but that goes back to the fact that this thing, basically, if you're looking at the graph, this graph, the part that we just found, again, I wish I could highlight it, was, actually, I'll just highlight it under here. Hang on, I'm gonna go back over here. So this thing looks like, I'm doing my best here, but like this, is that okay? Like between 0 and 2 pi. So this basically thing right here, we just found this whole thing because we went from pi over 2 to 3 pi over 2. And it just so happens that we kind of could see that if you would put this little yellow chunk on this little yellow chunk over here, if I had like put that over there, then these two things would match. Is that okay?
Oh.
And so then there's 2 of them and we doubled it.
Okay.
Yeah, whereas on the first one we did that. Now technically, I like how Emma was basically like, I was just eyeballing it and I think it was right. What lets us know that that's going to be the case is like if I would come back here and actually double check D. So if I would just say, okay, let's find the actual integral from 0 to 2 pi of this thing. Let's not go through the work of doing the Q thing because we already know it's just going to be e to the sine t from 0 to 2 pi. Well, sine of 2 pi is 1, or sorry, sine of 2 pi is 0, but e to the 0 is 1, and sine of 0 is 0, and e to the 0 is 1, and 1 minus 1 is 0. So that actually lets us know that part D is actually 0, which it does indeed let us know that these two things that we just said were symmetrical down here were symmetrical, and we can do what we did for part E. Ooh, those were good ones to do, though. Good choice, peeps. All right, what's next?
I need at least E on 6.
B or D?
E
I don't think there is an E on 6.
on 6?
Oh,
Or
no.
sorry. C.
I couldn't figure out any of 6.
Oh, I
Sweet.
guess C and D.
Let's
Yeah,
do
especially C and D.
Sweet. Recall that acceleration due to Earth's gravity is this. Will would hate this problem because it's in E. From ground level, a projectile shot straight up with a velocity of 90 feet per second. What this actually tells you, everybody, this does not tell you a velocity equation. This tells you an initial velocity. And that can be hard to kind of like wrap your mind around. So here's what I mean by this. Okay, so for part A, what we might want to do is we might want to go backwards from acceleration to get to velocity. But whenever we go backwards, like what would be backwards from just 32?
32 T.
32t or 32x. I'll use a t just because we're using time, but that's perfect. But wouldn't we have a plus c, everybody?
Yeah.
Yes, and so this is where this one does get a little bit tricky, because this is actually telling you that kind of v of 0 is 90. Is that okay? So this 90 feet per second is not like a v equation. It's not like v equals 90. It's actually saying, oh, in this equation now, you can plug in 90 for v and 0 for t and find c. Is that okay for everybody? So then c equals 90, right? So then our velocity equation is 32t plus 90, which actually is still not the answer, but it does give us what we can have to find the answer to part A. What do we do now with the 3 seconds to find the answer to part A?
Plug it in.
Yeah, just plug in 3. So isn't that 96 plus 90? So 186.
Could you make 32 negative? Since like it's gravity.
It would be negative, yeah.
Ha! Thank you, Olivia. Good call. Good call.
Yep.
Yes. So we are not. Nope. Okay. Good. Yes. This is negative. Okay. So 90 doesn't change, but this changes. So this is negative. Negative. Beautiful. We would. That would be hilarious. We live on a planet where you just fly off of the face of the earth at hurtling speed. Great.
That'd be fun.
That would be extremely fun until everyone's just floating in space and we're like, what's happening?
That'd be more fun.
So it's actually negative 6 feet per second. Does that look better?
Mm-hmm.
Okay, good call. Yeah, and basically what I'm assuming happens, everybody, is I think we're going to find some of this, is this thing gets shot up, right? And it's got a positive velocity when it gets shot up, and then it's going to turn around at some point. And so at 3 seconds, it's already on its way down. So part B says, when does it hit the ground? Well, there's a couple different ways to find this. What do you guys want to do?
I don't know if it's right or not, but I went from velocity to position, and then I solved for 0.
Yeah, that's one way to do it. I like that. So we could go backwards from V. I'll tell you guys one other way to do it, but I like that way. So let's do it that way. So backwards from velocity is position. So what's backwards from negative 32t plus 90?
Negative 16t squared.
Good. And then plus 90t.
90t plus c.
But it does say from ground level a projectile is fired. So did you guys know that that's actually telling you that the initial position is 0, right? It's at a height of 0. So you plug in 0 for S and T and actually C would equal 0 on this one. So we can get rid of that because C is 0. And then Olivia's totally right. Then we plug in 0 for this and just solve for T. And I think the easiest way to do that, to be honest, is to pull out a T. Because then we have this and we can just set both of these equal to 0. So at time 0, it's on the ground. And then if we solve this guy, that's also going to be what's on the ground. So I'm going to subtract 90, divide by 16. Anybody want to take 90 divided by 16 for me? Or Olivia, give us because you had it already.
I had 5.6.
Yeah.
Yeah.
Cool. And then if you guys want to know the other way to find it, we can actually, I need to think about this and make sure I do it right.
I did it using our physics formulas and got the same answer.
Yeah, I looked at this problem and I was like, I could probably use physics, but I don't think that's going to help me learn calculus, and I'm feeling lazy, so I didn't.
Because I feel like, now I'm torn. Because I feel like you should be able to set the velocity equal to 0 and solve. But obviously we're not going
That
to
would
get
give you the like where it slows down right before it falls, though. You want
Oh,
like
that's
where it's
true.
the fastest before it hits.
No, yeah, that would actually give you, I see what I'm saying. That would give you the point when it's at the top and you could just double it. How do you guys feel about that?
Yeah.
So you could do it that way, I suppose. So you could get negative 90 equals negative 32t. And my guess is if you take 90 divided by 32, actually I know this because 32 is half of 16, you're going to get like 2.8 seconds. And that would be when it's at the top, but then you could double it and get 5.6. There we go. So either those two. So then it says, when it hits the ground, what is the net distance it has traveled? I'm kind of annoyed that the book did this, but it's good. Basically, net distance is the same as displacement. And displacement here doesn't mean like maybe it traveled like 3 miles to the west or something. This literally just means it's displacement from where it started on the ground. So if it started on the ground and it ended at the ground on the ground, what's its distance?
0.
Yeah. That's actually C. But then D wants the total distance, right?
Mm-hmm.
So basically we got to figure out how high it went, and then we'll double that because that'll be how much it came down as well.
Could we plug in 2.8 for t in the position equation and then double that answer?
Yeah, I think so. I think that works. Let's do it. Somebody want to plug in? I like that way. That's good. Since we already know this is 2.8. Somebody want to plug in 2.8 to this and see what they get out. And then we'll double it.
$126.56
Yeah.
Is that before or after doubling?
before doubling.
Before.
Cool. So 253.12.
3.12.
There we go. 8. Excellent. So, I mean, this was just a weird way. I mean, like I said, this section is a little bit repetitive, but with new vocabulary, so it's kind of just great. Nice. Still moving on. This one just, wow, this section is crazy. And I can, just so you guys know, I can do as many questions as we need to. It's just at 11 o'clock, or probably like 5 till 11 or something like that. I have to go talk to the freshman children. Which Tyson might show up this time because he was on here on accident. But the first time I did it on Monday, I literally had 2 of them. So there you go. Okay. What's next?
7.
Number 7. Oh yeah, these all have to do with this picture, right?
Yeah, I didn't get any of those that do with the picture. I might have got 8, but I really don't know if it's right.
Basically, just know that like they're saying this has an area of 4, but if it's below, isn't it -4?
Mm-hmm.
And then this has an area of 5, but if it's above, it's +5. And then this is huge, I guess. That's not. So it's kind of like technically -24. So if it wants to know displacement between 0 and C, displacement is a straight integral, which basically means don't make anything positive. Does that make sense to everybody?
Mm-hmm.
So you literally have to take -4 plus 5 plus -24, which would give you -23.
Yeah.
Sweet. And is everybody okay with on number 8? You just make everything positive and add it together?
Okay, yeah, I did that. I didn't know if it was right or not.
Yeah, perfect. Do we need 9, 10, or 11? How you guys feeling?
Yes.
Wait, are 10 and 11 the same thing, or am I like not reading this right?
Yeah, I think
They're the same.
Okay.
They're the same. In the book, they're different. It was
I think
just
I
a
meant to make
typo,
it-
I think.
Whoops. Well,
It was
we'll
supposed
just
to be like 0 to
We'll
C.
just do
or something.
9 and 10 then, and then cross off number 11 because in your version it was the same as number 10. My bad. But I mean, as long as we talk about acceleration once, I think that's a good idea because this is a velocity graph, is what it tells us. So, number 9, it says give the positions of the particle at A, B, and C. This is where you have to know for 9, you have to know that its initial position was 15. Okay, so if its initial position is 15, it tells you that in the directions above. A would be, where does it end up after A? Well, what's the area between 0 and A?
4.
-4.
4, and it's -4, so that means it moves 4 to the left, right? So what's 4 to the left of 15?
11.
Nice. And then for part B, now you need to add 5 to that because it's going to go 5 to the right. So if we add 5 to that, we get
16.
nice. And then we got to subtract 24 from that.
-8.
Perfect. So number 10, approximately where does the particle achieve its greatest acceleration? So this is just really good to talk about just because, and it just says from 0 to B. So, and we can talk about what number 11 would be if we want, but what is acceleration compared to velocity?
The slope.
Right, so we actually haven't we have not been talking about slope at all yet on homework questions, and I didn't talk about it in the video because we're so concerned about areas this time, right? I mean, that's really our concern. But since it says acceleration and we're getting it from the velocity, it's actually the slope. So if you guys look in the picture here, I know my picture's kind of out of whack, but you could look at yours. What's the steepest slope, right? Because it says the greatest positive velocity. So actually we need the steepest slope in the positive direction. Where does it look like the steepest slope would happen?
Going from the bottom to the top.
Yeah, kind of like this
where it
area right here.
crosses.
At A.
Yeah, so kind of right at A. So at A would be the answer to number 10. Now, I think if you were going to do number 11 and you're going to do it without the typo, if it was supposed to be from 0 to C, I think the steepest would actually be over at C because it gets really steep over there. Sweet. All right, moving on. Do you guys need either the graphs 12 or 13?
I think I got 12, but I don't know about 13.
Yeah. I don't know about 13 either.
Yeah, 12 should have been 0 for displacement. Or so basically it should have been at 2 still at the end of the trip because its displacement is 0. And then total distance would have been just kind of the area of those 4 triangles added together, which I think is just 4. So that's number 12, I think. But yeah, we can do 13. So 13 gives you this crazy graph. Here's what you guys can either already do or just start to tell me, we need some areas, kind of like that one we just did. So we need the area of this triangle. We need the area of this big thing down here. And we need the area of this triangle. So I realized that my picture is going to be really bad. But so that was 3 tall. This was 3 tall. This was negative. So anybody have one of those areas for us?
The first one is
triangle
3.
3. The
This one's-
trapezoid is -12. And then it's 9 halves for the other triangle. If I did
Oh,
my math
man.
correctly.
4.5. I think you're probably right. Yeah, because this would be a base of 3, and this is a height of 3, and 3 times 3 is 9 divided by 2. Yep, and this one was 2 times 3. And you guys could have found the area of trapezoid in a bunch of different. Found a tiny triangle and a tiny triangle, and then the rectangle. Or you could actually just do the area of the trapezoid, which is
5 plus 3 is
1/2
2
times, yeah, the 2 bases times the height, which is 3. But the 2 bases are 1, 2,
It's 5 and 3.
5, and 3. Nice. So there we go. I like it. But that really helps you. As soon as you know that this is 3, this is 12, but it's negative, and that's 4.5. Boom, now we can do A and B. Because A wants where it ended, which, just so you know, I mean, there's two different ways to think about that. We can do it the way that we did the other one, but you do need to know it starts at 2, because they actually tell us that. Where it ended, just so you guys know, is always the start plus the displacement. So if you wanted to think about it that way, feel free. And that's literally what we did on the last one, because we just did 2, but then we added the 3, added the negative 12, because displacement means the negative stays negative. It's just like the true integral. And then added the 4.5. And so if we take this, which is the initial, plus the displacement, because that'd be the integral of all those together as they are, we'll get it, which is 5 plus, so 9.5. Did you guys get negative 2.5?
Yeah.
Sweet. Brilliant. And then part B is, what's the total distance? Well, how do we find total distance?
Add them together.
Positive.
Yeah, all positive, add them together. So 3 plus 2 plus 4.5. But we don't need the 3 plus 12 plus 4.5. We don't need the 2, though, because it doesn't want to know where it started. It just wants the total distance traveled in that time. So then 19.5?
Mm-hmm.
Sweet. I'm not going to do 14 and 15. Are you guys good that you would just like nint those?
Mm-hmm.
Like 14 just nint from 0 to 10 of that function.
I did it by
I mean, technically technically you can do that one by hand. Because
Yeah.
backwards you just have 25. So you could totally do that one by hand, but yeah. Then you just have to leave it unsimplified. And 15 is also a nint one.
darn. Okay.
Because daily would be 0 to 24. Yeah. And to be honest, just because I want to make sure we got 10 minutes, I want to make sure I get to one of these XY charts. If 16 is a little bit beyond you, there is not going to be anything like that on an AP test or something. I mean, it's just, I just watch my video again and try to do it along with that, because it's a lot like that population one. That's kind of dumb. I don't know. That one's stupid. So I just do it because I feel like it's in there, and I need to relook at Kaskaskia's final, but I'm pretty sure that's not on there either. So, did you guys want to do one of the 17 or 18 ones before we're done?
17, if everybody wants to do that one.
Yeah, sure.
That one made me hungry.
Bagels.
Yeah.
A bagel.
Bagel. We have bagels.
I had a blueberry bagel with cream cheese.
I do not
I
bagels, but
made bagels last week and they were really good, but they were a lot of work.
Part A is literally not a calculus-y type question. Do you guys know what you have to do for part A?
Is it? Wait, I did RRAM.
Right?
You actually, for part A, just have to add the, well, actually, technically, that's so weird. RRAM will almost work because you take it times 1, but technically, it's just adding the 5 plus the 8.9 plus the 16 plus the 26.3 plus, it's just adding all of the sales.
So just add 5 to my RRAM and then it's fine.
Yep. Did anybody want to say what they got for that, just so that people can watch it and double check
I
themselves?
got 797.5 thousand bagels.
That's what I got.
Boom.
Uh,
So that's all you had to do for that one. Then for B, they wanted you to actually, like, this is where, unless one of you did it, then I'm gonna have to like go bust out my calculator on my other computer. But this is where you have to go to the stat button on your calculator, right, and make like and enter in your chart. But they do tell you, I believe, oh, do they do? Yeah, they say X is the number of years since 1985. So that means like when you go to your stat button, your XY, like your L1 is usually what it is, and L2, right? When you're in your stat button, you're not going to be entering 1985 and 1986 and etc. You're just going to be putting 0, 1, 2, 3, 4, 5, 6, 7, etc. all the way down. And then 5, 8.9, 16, 26.3. And you're going to have to enter all those and then use quad regression. And that has been a while.
Will it not work if you put in like 85, 86, 87?
Technically, it will, I think the slope will be right, but what will happen is you're going to have like a parabola that's like way up in the stratosphere. It's going to be like
Yeah,
thousands.
that's what I did.
Yeah, that's what I did.
Okay.
Suddenly things are making a little bit more sense.
Here's what I can do. I'm going to stop my screen share and I'm going to flip my camera. But if my internet gets crappy, then maybe tell me to just stop and go back. But what I can do is I can go over here and enter it into my other computer. I just feel like I have so many things right now. So here's what I'm going to do. Since this is our last one, I'm going to bring up my calculator. Isn't this so cute? Look at all my little cuties. Anyway, I'm actually wearing the same shirt in that picture as I am right now. I promise I changed clothes. It's quarantine. I didn't change clothes since the musical. Okay, this thing takes a while to load. But basically, we're going to have to type in this information. So somebody may have to be ready so they don't have to switch back and forth screens to read me the number of bagels. But right now, I've got to use 0, 1, 2, 3, 9, 10. So I got to use 0 through 10 here. So this is where you go to Stat, Edit, and then, hey, I already have a bunch of stuff entered. That's great. 7, 8, 9, 10. Okay. Sorry that somebody has to read this to me, but somebody want to read me the number of bagels?
5,
5, got it.
8.9,
8.9, got it.
16,
16, got it.
26.3,
Got it.
39.8,
Got it.
56.5,
Got it.
76.4,
Got it.
99.5,
Got it.
125.8,
Got it.
155.3,
Yep.
188.
Boom. Okay, then I go to Stat, and then I go over to Calculate. So that guy. And then I want Quad Reg, right, which is number 5. And then I've got the fancy calculator, so I got to scroll down here, press Calculate. Boom. So now I'm just going to go to the whiteboard so that I don't have to go back.
Wait, that's what I got.
Yes. Excellent. So this is y equals 1.6 x squared plus 2.3 x plus 5. And that's part B. And then part C wants you to integrate that from, so what wouldn't this be from 0 to 10 then?
Yeah.
Over a 10-year period? So just so that we don't have to do this one by hand, since we had to do all this in the calculator anyway, I definitely think we should use NINT to our advantage. So I'm going to plug this into NINT right now. So 1.6 x squared. I'm glad I didn't lose internet over here, buddy. This is great. 2.3 x plus 5 dx. And I get 698.3. So how does that compare to our part A? What was our part A again?
797.5.
And so then part D just wanted to know, why are they different? So what do you guys think? Why do you think they're different?
Isn't it just because the regression we did is not at all accurate?
Yeah, basically it's because the regression equation like kind of connects things in a smooth curve. And like what we did when we added things was the exact information. It was just adding kind of like rectangles, kind of like Abby was saying for like our RAM. So basically it's because it's not the same function, right? One's an XY chart function, but perfect. They're not going to be at all accurate because of that reason. Whew. Okay. I'm going to stop recording because we've been recording for a while.